first one is just a piece of information with some thoughts about that. That was a astronomer's telegram, which was published yesterday by the CHIME collaboration. And they reported that they had seen a burst from a well-known magnetar. It's SGR 1935, and this is the famous magnetar that has released a very, very intense pulse, maybe 3 years ago, something like that, which triggered the idea that magnetars might be the origin of fast radio burst. Ever since that, there have been many bursts observed from this magnetar, but not as strong, just sort of ordinary bursts. And yesterday, the CHIME collaboration reported again a very intense burst, not as intense as the first one, but it was again the same situation. It was not received directly. They saw something, it has the right dispersion, but it was received off axis, so it was into the side lobe. And then that makes the judgment quite difficult. But I think the key message here is that they estimated a flux density of 20 kilojansky or more, kilojansky times millisecond. So that's a pretty intense burst. And the reason why I bring this up is now we know that this magnetar does these extremely intense bursts not only once, but maybe repeating it every couple of years or so. Anyway, what I thought is, if I look at the numbers, 20 kilojansky milliseconds, we're getting in the range where a small dish can observe such a burst. It's at least in the ballpark. So it may be something that some people might be interested in just doing or spending a lot of observation time. The chances are not very high that you get something because they are very infrequent, but that's something that at least we would be considering to use spare time of our small dishes to just track this magnetar and see if something else happens. A final comment on that. The very first very big event that was not only recorded by CHIME, but also by a project which was called STARE-2. It's sort of a radio all-sky camera. I haven't heard that they have observed it as well. So maybe they're not sensitive enough. I'm not sure. Anyway, but this is not really the most interesting thing for us, which I want to report, because there was a second on the same day. Actually, I read it this yesterday morning. There was another report from the CHIME collaboration. CHIME had detected a repeating FRB just about a month ago, fairly new detection in September last month. And they reported that they had seen multiple bursts in the last couple of days. So they said they had 9 bursts within 3 days. I'm showing on the right-hand side their strongest burst, and they made an estimate. They say, okay, since this source is passing through our beam for a certain period of time, if we extrapolate that, they said, well, there may be as many as 200 bursts per day in excess of 1 Jansky millisecond. And that triggered our interest. 1 Jansky millisecond is not enough for us. And also, if it is a fairly widespread pulse like this one, what they had observed, we would not be able to observe it. But we said, okay, if they expect something like 200 per day, there may be one or another which reaches our detection threshold. So we started observation, and here we go. This is a fast radio burst from that source. It occurred, we were just something like 2 or 3 hours into our first observation. I don't have a number on the flux density yet. I have to go into the calibration data and look at it. My estimate, this one is something like maybe 10, 20 Jansky milliseconds fluence pulse. Well, for us, the nice thing is that we had something like 20 pulses from another FRB over time. This one is the one that we observed previously was is silent right now, but now we have something new to look after and keep our operators busy.
Is this with your 25-meter dish?
Yes, that's with a 25-meter. Yeah.
Mm-hmm.
Okay, so that's brand new, and as we speak, the observations are ongoing. We haven't seen any more yet, but we'll see what happens.
Excellent.
Wolfgang, if going back to your Magnetar observation for this group, what is the setup that they would do, the frequency, what is the data that they should collect, and how do they know they got it?
Well, essentially looking at a magnetar, like where we are doing ongoing observations of the magnetar. This is essentially, in the first place, is just like any pulsar. It's a fairly slow pulsar, so you do the same thing. But on top of that, at least for the one that we are observing, it emits strong pulses every now and then. The frequency of these pulses changes over time. Sometimes it's fairly high. Sometimes they're just 1 or 2 per day. And the detection of the sort of continuous signal is just like with a pulsar. You fold the profile with the right dispersion measure and look at whether you have enough signal to noise ratio. For the single pulses, you essentially have just a single event. You need to de-disperse the data. And the way, maybe I go back to this slide because I can sort of demonstrate that there. The characteristic of a astronomical origin is, first of all, it has to be dispersed. So this is really after de-dispersion. If it would not be de-dispersed, this line which goes across the frequency would sort of go like this, because the higher frequencies arrive earlier than the later frequencies. And if it's spread out, obviously you won't see the pulse. But if you de-disperse it so that all the frequency channels appear at the same time, then you get a pulse. The important sign of this being of astronomical origin, obviously, is that it has to be a wideband signal and it has to be de-dispersed. Actually, you can see in contrast to that, the 2 bright spots here. This is RFI, at least most likely. They just happen to be at the same time as the FRB, but they're narrow band and they're pretty bright, but they're narrow band. So if you have, let's say, a signal where you have scattered dots around, this is typically a radar signal. But if you have something that goes all across the band, more or less continuously, maybe showing some variations in intensity, this is a sign of scintillation typically, then that's what it could be, either an FRB if it's from a large distance, or in case of this one magnetar that we are observing, it can be a pulse from the magnetar.
Okay, so when you said using small dishes to observe, it's small dishes that are set up for pulsars, not the hydrogen small dishes for this magnetar.
If I would not expect that you would see sort of ordinary pulses from the magnetar. I'm referring to this one specific magnetar, which has emitted in the past an extremely bright pulse and has a very bright pulse just recently released. And I still need to go through the numbers. Obviously, if there's something which is a 500 kilo or a 1 megajansky millisecond, you would see it with a small dish easily. At 20 kilojansky millisecond, I have to go through the numbers, but it seems to be in the ballpark of being able to be seen with a small dish. The challenge there, of course, is those pulses appear very, very rare. I mean, there have been years between, so you really have to be patient, and at the same time record data. And there's a lot of data and a lot of analysis, so it's quite a task. But it maybe it's more a theoretical possibility than something that you would do in reality, but at least it's worthwhile thinking about it.